This is the slide. Hello, my name is Karim Dada. So I'm a mechanical engineer. I work for Arab. Today I'll be presenting Design by Code. It's a new workflow for building simulation, automation, and optimization. So I'm just going to go really quick. We've got a lot to cover here. At the beginning of the project we're looking at, we set out a design manifesto, basically setting out all our design principles. I want you to focus today on 3 of those. Shaping the design using the environment, so basically looking at solar analysis, wind analysis, precipitation, ground temperatures, all of kind of environmental metrics that you can find. Automatically, when you start thinking about these, you start thinking about all the different tools that you need to use to be able to simulate and get your results out for the project. The second one I want to focus on is this is a movable adaptable. So this is a hotel. It's supposed to be packed up every few years and moved to a completely different climate location and climate, basically. That brings in a lot of challenges because one, all of the simulation has to be redone, and also the project has to be designed from day one, taking into consideration all the different climates, all different simulation, all this enormous amount of data. And this brought us to our third and most important principle, design by code. When we started thinking about the complexity of the project, all the simulation, the data that we're going to be producing, how do you handle this? And I'll show you throughout the presentation what design by code actually means. So just to take you really quick through it, that's the project. You've got a main hub, and which is a restaurant, and it's a hotel, and you've got pods all over. Each pod is basically 1 to 2 bedrooms, so we wanted to optimize the master plan, the pod massing, the shading analysis, everything that you can go through it. Looking at workflows, we sat down as a whole design team, and we literally started mapping out every single step that we're going to take, every single simulation tool, every single design check, every piece of information, how we're going to get it, how we're going to present it, how we're going to pass it on. So there's 3 main steps here. Is 1, mapping the whole process up, which is the first stage. Second stage, how do we automate all of these all of these steps? And the third one is how do we optimize? This is very crucial to be able to handle the project. Going a bit deeper into this, that's one part of the script, one part of the workflow. The way we look at this is you've got different components. One of them is piece of information in blue, and then in green is something that you do to that information. So you might, it might be simulation, it might be data analytics, and then you start producing information. That's the yellow component, and then you check it. Does it pass? Does it not pass? You go through iterative process, maybe redo your simulation with different variables, come up with a different answer, and then see how it goes. For every single one of these components on the top, we started relating you see at the bottom part, we started writing code. So we replace every single step by a piece of code, by a piece of algorithm, by a piece of simulation software. Each one of those steps has becomes codified. And that brought us to our automation. The second step in this, looking at it from a higher level, we've done all our workflows, we thought about how we're going to go through the project, and for every single one of them we've written our scripts, we've done the weather analysis, that passes information to renewable energies, which passes information to the master plan optimization script, which then goes on to the pod optimization, changes the geometry, and that changes the structure. You realize here that every single one of those disciplines is working in scripting. Everything's done by coding. There is no, everything's done by scripting. So any changes directly reflected throughout the whole project, and the data transfer is instant. What is important about this is how do we do this? It's, everybody looks at this, it might be, yes, this is Grasshopper, this is Rhino, but we're not focusing only about parametric design. We're focusing about digital infrastructure. It's taking one piece of information, reformatting it, and then passing it along to different softwares. I mean, going through a CFD, energy analysis, radiance analysis, daylighting analysis, even our MEP calculations. If we wanted to do it manually, we'd have to remodel the building, re-put the variables, and every time we do second iterations, we have to match it all over the software, process the results, and find a way of combining everything. By doing this, working through digital infrastructure, that is completely automated for us. one model goes with the parameters throughout all of the software packages that we need, and then all the output is recombined at the end as a holistic result. So at the end, you get a custom tool that's able to look at multiple disciplines and opens up many more advantages, I'll show you later. Okay, this is, yeah, 1 minute. Yeah. So yes, automation is very good. You can go out to hundreds and hundreds of options, but actually that's not the point, because even if we can go down from weeks to a few hours of computation, what we wanted to do is even optimize more. So we use genetic optimization algorithms and even more reduce the computational time that we needed to go through all the possible options. And one more thing that we also did is, through every single step of the process, we looked at the variables. Okay, yeah. So through the process, we did the sensitivity analysis of all the variables. So taking every single variable, seeing which ones actually makes the most difference on our results, and then in which range. Yeah, I'll stop here.
Great, thanks very much, Karim. Judges, one question for Karim.
So it's very interesting that you incorporated the MEP and the load calculations within the simulation.
Yes.
Changing the building form.
Yes.
Did you do any validation in terms of those calculations with other software to make sure that the results you're getting out is correct?
So we did, yes, we did design checks at every single step. So what you see in our workflows, we had a few red spots, which maybe I can show you. And it's design checks, and it's validating against benchmarks and past experience. And the good thing about working in this way, every single time we run these simulations on different projects, we start creating a database, watts per meter squared, and all the stuff that we can benchmark against, and that's kind of one of the validation points that we did, yes.